So in this lesson, it's basically review. We're just doing a few examples solving linear equations for a variable. So we're just using our algebraic properties and performing algebraic operations to be able to solve for an unknown variable. You can always check your answer by substituting in the value of that variable back into the original equation. And if you get an identity, a number equaling itself, then you're good to go. So let's go ahead and talk about how we would solve in this first example for x. Now, feel free to try these on your own and see if you get the right answer. So feel free to pause it at any point and work the problems and then check to see if you did it the same way. So in the first example, what I would do is I would distribute that minus sign, that minus 1, to each of the terms inside the parentheses. On the right-hand side, since it's just addition, we can merely drop the parentheses. So that would give me 5x minus 2x minus 2 equals x plus 3x minus 5. So on the left-hand side, I can combine like terms. On the right-hand side, I can combine like terms. And I would get 3x minus 2 equals 4x minus 5. Now at this point, we want all of our x's on one side of the equation. So perhaps if you want to try to keep your x's positive, perhaps you would want to move the 3x to the right-hand side of the equation by performing the opposite operation, subtraction. So that would give me minus 2 equals x minus 5. Now, still solving for x, our next step would be to isolate the x, add 5 to both sides of the equation. So ultimately, that would give you x equals 3. So to check this, because you can always check your answers, you would go back to the original problem, and everywhere you see an x, you would substitute in our value we obtained for x, 3. So that would be 5 times 3 minus 2 times 3 plus 2 equals 3 plus 3 times 3 minus 5. And then just perform the operations. 15 minus 6 plus 2 equals 3 plus 9 minus 5. Continuing to work what's inside the parentheses, that would give me 15 minus 8 equals 3 plus 4. So that would give me an identity. 7 does in fact equal 7, so this was the correct answer. Now, try the next one. See if you can get the next one. Okay, I would distribute the 4 to each of these terms, distribute the 3 to each of those terms, giving me 8x plus 4 equals 29 plus 6x minus 15. Now, on the right-hand side of the equation, I could combine my constants, bringing everything else down. So that would give me 14 plus 6x. At this point, I would want to get all my x's on one side of the equation. I would subtract 6x from both sides, giving me 2x plus 4 equals 14. Then I would move the 4 to the other side by subtracting, which would give me 2x equals 10. And then the last step, divide both sides by 2. I kind of gave the answer away there. Let's go ahead and do that more neatly, a little bit neater. Divide both sides by 2. So that would give me x equals 5. And again, to confirm that we obtained the correct answer, I would substitute back into the original equation to make sure you got an identity. Now, in the next example, you notice that you are adding and subtracting fractions. Now, we know before we can add or subtract fractions, we have to have a least common denominator. So you're trying to figure out what number, preferably the smallest number, the least common denominator, that you can get that each of those denominators, the 5, the 2, the 3, goes into. You could always multiply them together and get a common denominator. The least is the best. It saves you a few steps. But now we have to ask ourselves, what am I multiplying by each of these fractions, each of these terms, so that I can get that denominator, that least common denominator of 30? Well, in the first instance, I'm multiplying by 6 over 6. In the second term, I'm multiplying by 15 over 15. And in the third term, I'm multiplying by 10 over 10. So let's go ahead and perform the multiplication in the numerators. So I have 18x, that was over the common denominator 30, minus, now I have to distribute that 15. So if you want to go ahead and distribute first, that would give me 15x minus 45, again over 30, equals, and then again distribute, 10x plus 20 all over 30. Now you will see once you have the same denominator across the entire equation, every term has that denominator. I technically could multiply each of those terms by 30 and get rid of the denominators. And I think I'm going to go ahead and do that. So that would just leave me with 18x. And now I would distribute the minus sign. Minus 15x plus 45 equals 10x plus 20. Now that's a much more attractive equation for us to solve. I'm going to go ahead and combine like terms on the left-hand side. So that would give me 3x plus 45 equals 10x plus 20. I need to get all my x's on the same side, so perhaps subtract 3x from both sides. And if you want to, at the same time, address the constants, move this to the other side. Oh, and that's a 20. Okay, so that is going to give me 25 equals 7x. Our last step would be to divide both sides by 7. And that gives us the value of x being 25 over 7. Now you may look at that and say, oh gosh, that doesn't look right. But I don't know why you would say that. There's nothing wrong with obtaining an improper fraction as the value of x. Substitute it back into the original equation. You'll get it. Now, here are some more exciting problems, a few more operations for us to do. Do go ahead and pause the video and see if you can work these out, solving for the value of the variable, solving for y in the first one, and then solving for x and y, allowing you to simplify evaluate the last example, and then feel free to check it. So you can pause it. Okay, I am going to first distribute, paying very close attention to the signs at the same time. So 45 minus 4 minus 2y minus 4y minus 28, be careful of those signs, equals negative 4 minus 12y minus 4 minus 3y minus 6 minus 4y plus 10. So I did a bunch of distribution. Now I'm going to combine like terms. So I see some y's I can combine here, and I see some constants I can combine here. Inside the other parentheses, I do see some constants I can combine. And again, I see some y terms I can combine. So let's see what we get. And then I have minus 24 minus 6y. Making sure I don't lose anything in the process. Okay, so 4 minus 6, negative 2, plus 10 is 8. And then my y's. And then again, I'm going to distribute. I'm going to subtract each of those terms. I'm going to subtract each of those terms. So I'm going to rewrite it. Okay, now I want to eventually solve for y. So is there anything I can combine on the left-hand side? Absolutely, constants. So if I combine those, I'm going to get 69 plus 6y equals, let's see what we can combine on the right-hand side. I have some constants, so that gives me negative 12. I also have some y terms that I can combine, minus 5y. Ultimately, I'm solving for y, so what might you want to do to keep your y's positive? I would add 5y to both sides. So that is 69 plus 11y equals negative 12. Then I would subtract 69 from both sides. And that would give me 11y equals negative 81. Divide both sides by 11, and I get my value of y to be negative 81 over 11. Again, you can check your answer. Now, let's look at the next one. In the next problem, you're asked to evaluate this expression. So ultimately, I want to evaluate this expression. However, I don't know the value of x or y, but I do know that that expression, x satisfies this and y satisfies that. So I can solve each of these independently for x and y respectively, and then once I get the value of x and y, I can substitute back into this original expression and evaluate it. So let's go ahead and take this first one. 13x minus 6 over 4 equals 5x plus 2. So I'm going to solve that for x. And then I'm going to solve this equation for y. Okay? So in the first example, you see that you have a fraction set equal to a fraction. Technically, this is a fraction. So I can multiply across the equality. So that means I can take this and multiply it by that and set it equal to this multiplied by that. So that gives me 13x minus 6 times 1 is itself, and then 4 times 5x plus 2. Now, what else could I have done? I could multiply both sides by 4, and it would give me the same thing. Now, at this point, I'm going to distribute. So I have 13x minus 6 equals 20x plus 8. I'm going to solve for x by first subtracting 13x from both sides. So far, so good. And then move the constant over by subtracting the opposite operation, which gives me 7x equals what? Negative 14. Then divide both sides by 7. Oops. I say 7 and I write something else. And that gives me x to equal negative 2. So I now have the value of x. Now I'm going to come over to this equation and I'm going to solve for y. So to do that, I would first distribute, giving me 5 minus y equals 7y plus 28 plus 1. Let's go ahead and combine the constants here. So that's 5 minus y equals 7y plus 29. Now let's get my y's on the same side. Okay. And then let's move our constants. So that gives me negative 24 equals 8y. Last step, divide both sides by 8. And I get y to equal negative 3. But I'm not done. but I do have the value of x and y. So now I can return to this original expression and substitute in for x and y, and I can evaluate that. So let's go ahead and do that. So then I have, let's see, x was -2, so I have -2 quantity squared minus -2 times, what did we say y was? -3 minus -3. Okay, so that would give me, 4 minus 6 plus 3. 6 plus 3 is 9. 4 minus 9 is -5. So my final answer is this. I have evaluated this expression after having found my value of x and y. And that's it.